The title of this presentation is CubeScan, How to Manage 3D Point Clouds. CubeScan is our new 3D software. It is part of Stonex Cube Suite, and it is a desktop software to manage 3D models. So thanks to this software, it's possible to combine 3D point clouds and extract some information from this 3D model. It's a user-friendly software. It's easy to understand and find the tools. It's affordable, and it is a software that you can use thanks to a USB dongle. So the license of this software is on a USB dongle. And of course you can install this software on many PCs, on many desktops, simply moving the USB dongle from one computer and the other. This is the interface. You have a main central window with the 3D model. On the left, you have the project window where you have the list of all your point clouds. Then you have the property window, so selecting one scan, you can know some property of this scan. And then on the left, you have the station manager. So depending on how many scans, how many point clouds you have opened in the 3D view, in the station manager you have listed all of them. And you can choose to view one of them or not. Let's see the functions. So there is an edit window where there are some tools to view your scans. You can choose to see your scan from the top, from the front, in the bubble mode, or in a 3D free view. You can select part of points of your point cloud, and the selection can be defining a rectangle, a polyline, a segment, or you can slice create a slice of your point cloud. And then there are some delete tools to delete what you selected, or maybe create like a filter of choosing an elevation or a radius, and delete everything what is above, below, or inside or outside. In the measure window, you have tools to get distances, to know heights, to measure angles, and also to measure area, and also projected area. In the pre-process window, there are tools for filtering your point clouds, to downsample, to create the segment. Create the segment means that the software will search surfaces and will create a segment for each surface. It's possible then to evaluate the inclination of surfaces. If you work with the reflectance, with intensity color, you can modify the end cut part of the histogram of your reflectance, and so improve the black and white effect. And then you can adjust your point cloud with respect an horizontal plane or with respect a vertical plane. CubeScan has many register tools. We have the known station, unknown. CubeScan has many register tools. We will see later more in detail. All these tools are useful to align, to merge together the scans coming from different sensor or from a laser scanner. For the output, it's possible to create edges, choosing two different planes, or create automatic edges. So simply the software automatically will find the edges of the point cloud. It's possible to calculate contour lines and the orthophoto. Then in the layout tab, you can also modify the display setting, choose if you want a different layout. The software is a software which has the aim of merge together, of integrate point clouds coming from different sensors. We have in this screen the X300 laser scanner, the F6 handheld scanner, and results from photogrammetry. So you perform a survey with your UAV drone, you post-process the photos by using a photogrammetry software like CubeFly software, and then all the results, which are point clouds, can be merged together in the CubeScan software. For example, here you see this is a point cloud coming from CubeFly. I open this point cloud in CubeScan, so it's a photogrammetry point cloud. In CubeScan, I already have registered some scans coming from X300 laser scanner, and these are these 10 scans. I merged together these 10 scans, creating this X300 union. And now I open these scans with the photogrammetry survey. You see that the two data can be merged together, and so create maybe models with different sensors in order. Maybe it's easier with a UAV drone have elements of your field, but for a case like this in the image where there is a query, the facade of the query can be scanned by a tripod laser scanner. That integration allows to increase the quality of your final survey. I said that there are many registration tools in CubeScan. These tools can be chosen depending on your application, depending on which elements you know. For example, you can know or not the station position. Station position is the position of your X300, of your laser scanner. And the software will use these informations to merge together the scans. Then it's also possible select manually some points to use for the registration. So the user chooses 3 or more homologous points, there are many other registration tools that now we see more in detail. In the table you see that for some registration tools it's necessary to know the station location, and maybe for other tools it's necessary to have performed some other processes before. For the known station, it means that you know the position, the coordinates, where you set the tripod of your laser scanner. So the position of X300 laser scanner is known. And thanks to that information, the software will position the scans in the correct way and will match in the best way as possible the two scans to have a result like this one. If you don't know the station position, it doesn't matter. It's possible to merge together scans without knowing the station position. The software will find by itself some homologous points, some common points between the two scans. Of course, it's necessary to have a certain overlap between scans. And the result is always the same. Then there is the station redirection. So for that tool, you need to know the station position, and you need to know another point that is inside your scan, inside your point cloud. So you will say to the software to do an orientation to this other point that you know. Then there are registration tools by using 3 points or 3 planes. In both the cases, you will need to specify which are these 3 common points or these 3 common planes in the scans. If you select 3 points, you will have a window like this one, where you go to define which are the same points in 2 different point clouds. And the result. The 3 points are overlapped because they are the same points. Then there are the tools which use one station and one common point, or one station and one common plane. So you see that there are the 2 station positions, and in both the scans there is a point in green which will be used to adjust and to register the point clouds. Once that you have performed your registration, you can proceed with all the other tools. So there are tools to get measures and to extract points. as you see from the image here, there are some distance measures. There is an angle measure and an area measure. All the points that are picked on the screen are listed in the table on the right. And of course, all these measures, all these points can be exported as a TXT file or DXF. It's possible to extract an orthophoto. So going in output orthophoto, you select very quickly an area where you want to create the orthophoto. This area is highlighted in red, and then you see that there is a generation of this yellow box. Thanks to the dimension and correction window, you can fix and modify the dimension of this box. You can shift it, you can increase it as dimensions. It's important that this box contains everything what you want to see in your orthophoto. And so you need to center it. It's also possible to modify the thickness of your orthophoto. So now I'm reducing the far and near planes, because I want to have only the facade inside my orthophoto. And then you have the preview of your orthophoto. And you can export the orthophoto as a PNG file. And here the result. So the orthophoto is an image, a scaled image, where you can take measures, because you know they are real coordinates. Then it's possible to generate contour lines. You have a result like this. The contour lines are generated with respect to the XY plane. And the last tool I show you is the edge extraction. Of course, the first step is create the segmentation. The segmentation is the procedure which divides your point cloud in planes. Then you can choose by yourself which planes consider for the edge extraction, and you have a result like this. So the software will find the intersection between the two planes, or if you choose the automatic tool, you simply define some parameters, and the generation is automatic thanks to this segmentation, and this is the result. And of course you can export them as DXF. Stonex technologies can be integrated. You see, we already have talked about X300 laser scanner, but you can create point clouds by using the F6 handheld scanner, or very soon with the X800 laser scanner. These hardwares can communicate in a Stonex 3D reconstructor or in CubeScan, or if you prefer in another in a third-party software. Because in all the cases the elements you are going to use is a point cloud. And the same is for the photogrammetry applications. So also from CubeFly software and Zephyr, another photogrammetry software, you obtain again point clouds, which can be used in Stonex Reconstructor or in Autodesk or other softwares to merge photogrammetry applications with laser scanner point clouds. With respect to Stonex Reconstructor, CubeScan has less functions. 3D Reconstructor has more specific functions for some fields, but CubeScan, the idea behind CubeScan is to have a software which allows you to merge together the scans, the point clouds from photogrammetry, and extract what you need to use maybe on other software, to use this information in AutoCAD, for example. Now I highlighted in this slide what CubeScan doesn't have with respect to Reconstructor, so the red highlights. And then there is a green highlights that is the station redirection tool, which is available only in CubeScan. Thank you for your attention. And if you have any question, you can reach us at Intergeo@stonex.it.